Smelling something dangerous may put the immune system on high alert. And this is a picture of a roundworm. Obviously, it's a parasite. One of the most studied organisms on Earth has a nose for danger that scientists are just beginning to understand. The mere whiff of dangerous bacteria is enough to put the immune system of a roundworm on high alert. Like humans smelling off food from the fridge, the olfactory neurons of the nematode Caenorhabditis elegans, the roundworm, may serve as the early warning sign for bad food. Instead of stopping the worm from eating the pathogen, however, the stink of harmful bacteria prepares the worm's gut for the worst. Before the food is gobbled up, the worm's intestinal cells begin destroying energy-producing organelles called mitochondria. These cellular powerhouses contain a bunch of iron, which most invading bacteria need to carry out a successful infection. By removing mitochondria from their intestinal cells, the worm's body is hindering a future infection from taking root. Researchers at the University of California, Berkeley, suspect that the preemptive response evolved to protect nematodes from lethal pathogens. C. elegans, the roundworm, needs to eat bacteria to survive, but knowing which cells are nutritious and edible and which are potentially harmful is crucial to the worm's survival. Without specialized eyes, one of the only ways for the nematode to tell if a meal is dangerous before swallowing it is to detect the smell of toxic bacteria. It does this via the natural byproducts shed by bacteria into the environment called volatile metabolites. A bacteria that kills, C. elegans, a roundworm called Pseudomonas aeruginosa, produces a metabolite called acetylpropionyl, and in experiments, the olfactory nervous system of roundworms was able to detect acetylpropionyl, and when it did, it triggered a mitochondrial stress response in the worm cells, which was particularly detected in intestinal cells with staining. These olfactory neurons are in constant lookout mode when there's no odorant detected, becoming silenced when they detect an odorant. So when the scientists silenced the olfactory neurons, the worm cells remained in a state of preemptive immune response, regardless of the presence of an odorant. The novelty is that C. elegans, the roundworm, is getting ready for a pathogen before it even meets the pathogen, says neuroscientist Julian Dishart. There's also evidence that there's probably a lot more going on in addition to this mitochondrial response, that there might be more of a generalized immune response just by smelling bacterial odors. Whether that extends to other animals with even stronger olfactory nervous systems is unknown. Dishart thinks that because the olfaction is conserved in other animal lineages, it's totally possible that smell is doing something similar in mammals as it's doing in the roundworm. Further research, of course, is needed to investigate if smells can prime the guts of other animals in a similar way. Is there actually a smell coming off the pathogens that we can pick up on and help us fight off an infection? Wonders neuroscientist Andrew Dillon. We've been trying to show this in mice. If we can actually figure out that humans smell a pathogen and subsequently protect themselves, you could envision down the road something like a pathogen protecting perfume. The study was published in Science Advances, and this is by Carly Casella on Science Alert. Please leave your comments. Thank you for your support. Finally, support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.